Hey everybody, so in this video we're going to be doing some more examples of applications for functions. So let's move on to number 4. The price-demand equation for a certain product is P of x equals 100 minus 0.25x when x units are produced and x is between 0 and 300. So for part A, write the revenue function R of x received for the sale of x units of product. Right, so let's break this down just a bit. So first off, the price-demand equation. Right, that's what this right here is. What that means is it's just the price if you make a certain amount of the item. Right? So if you made 1 billion of an item, right, people may not actually need 1 billion of that item. And since there's so many of them out there now, the price would go down. Right, so essentially this is just a simple way of saying the more you make, you might have to sell it for a bit less. And this function gives you the price that you're going to be selling it at. All right, so in general, this is the price. All right, now we're wanting the revenue function. All right, here's how we find revenue. The revenue, R of x, is just going to be x, which is the number of units, times P of x, which is the price. Alright, so all we're saying with this is the revenue function is the number of units that you're wanting to sell times the price that you're selling them at. Alright, so let's go ahead and do this. R of x is just x times our price function, which in this case is 100 minus 0.25x. Alright, if we multiply that out, we get 100x minus 0.25x squared. And if we just rewrite this, because we're used to seeing the exponents in order, it'd be negative 0.25 x squared plus 100x. That is our revenue function. All right, for part B, what is the revenue for 100 units? So we're looking for revenues, that was R of x. And if we want it for 100, we just replace that x with 100. So it's going to be negative 0.25 times 100 squared plus 100 times 100. Multiply that all out in your calculator, and you should be getting $7,500. Alright, so if you make 100 units, you can expect to get $7,500 in. Alright, part C, how many units must be sold to maximize revenue? Alright, now this one's going to be a little bit different. Alright, so we're dealing with a quadratic function because we have that square in there. Alright, to find the maximum of a quadratic function, you need to remember one thing. Negative b over 2a. If you can remember this, then you're going to be good to go for maximizing revenue and maximizing these different functions. All right. So to use this, that a and b are the same a and b as whenever we were talking about split b, whenever we're doing quadratic formula. A is just the number with the x squared. B is the number that's just with x. All right, so how many units must be sold to maximize revenue? Since we're talking about revenue, we're talking about R of x. So we have A is negative 0.25 and B is 100. We just plug them in to this formula. So it's negative 100 over 2 times negative 0.25. So that'd be negative 100 over negative 0.5, which is 200. So 200 units will maximize the revenue. All right. Part D, what will the maximum revenue be? All right, to find the maximum revenue, well, we know how many units have to be sold to find the max. That's what we found in part C. So we just plug that number of units that we just found into the revenue function. So we're going to do R of 200, because 200, we know that that's what gives the max. And that's from C. Alright, so if we just plug in 200 back into this original revenue function that we have found in part A, it's going to be negative 0.25 times 200 squared plus 100 times 200. And if we just plug all of this into our calculator, then you should get $10,000. Alright, so if you sell 200 units, then that would give you the maximum revenue. Because if you end up making more units, then the price goes down far enough to where you start losing revenue in the end. Alright, number 5. The price per unit of a certain product is modeled by the price demand function. That should be f of x. Oops. Or to keep the naming convention going, I'll write that as p of x. So p of x equals 300 minus 2x. The revenue function describes the total revenue received when X units are sold. So again, part A, write the revenue function for the product. So same thing as we just did. We know R of X is just X times P of X. Alright, so it's going to be X times 300 minus 2x, which is 300x minus 2x squared. And again, just to keep things consistent, I'm going to go ahead and write this as negative 2x squared plus 300x. And this way, the exponents are already in order. All right, for part B, how much revenue is received when 10 units are sold? All right, so for 10 units, that means we're just going to do R of 10. So it's going to be negative 2 times 10 squared plus 300 times 10. Plug that into your calculator and you should get 2,800. So if 10 units are sold, $2,800 is what you're getting in. All right, part C, how many units must be sold to maximize revenue? All right, so again, just remember negative B over 2A. This is what we use to maximize things. All right, so for our revenue function, A is negative 2 and B is 300. We just plug them into that little formula. So negative B will be negative 300 over 2 times A, which is negative 2. So it would be negative 300 divided by negative 4, which would be positive 75. So 75 units will maximize the revenue. For part D, what will the maximum revenue be? We just take the number of units that we know gives us the max and plug it in. So we're going to do R of 75. So for R of 75, it's going to be negative 2 times 75 squared plus 300 times 75. Plug that in your calculator, and you should get 11,250. That would be the maximum revenue you can make by selling those 75 units. Alright, so I'm going to go ahead and stop the video here so it's not too long for you guys. In part 3, we'll be taking a look at some more, talking about averages next. So make sure you watch the next video to see how the rest of them are done. It's not just more examples, it's different examples with some new stuff that you still need to learn. So make sure that you go take a look at the next video. And with that, see you in the next one.